Alright folks, for this particular video I want to show you how to graph a quadratic equation that is in standard form. So in standard form we're looking at an equation that's in the form y equals ax squared plus bx plus c. And all the things that we talked about with vertex form in regards to a still apply here. So since a is a positive value, this particular quadratic equation is going to open up. Now, finding the axis of symmetry is a little bit different for this particular form because it's not as easy as looking at the equation like it was when we had something that was in vertex form. So for the axis of symmetry, we actually have to do a little bit more work. So we have to remember that equation. X is equal to the opposite of b over 2a. And once we use this, again, little shortcut method, we can just plug our values in from our original equation, looking at what b is, and knowing that that is the opposite of 2, divided by 2 times my a value, which is 1/2. If I go through and do the math, then 2 times 1/2 on the bottom gives me 1. Negative 2 divided by 1 gives me negative 2. So my axis of symmetry is at x equals negative 2. Just like in vertex form, the the axis of symmetry is also the x value of the vertex. So I just have to do a little algebra to figure out what the y value of the vertex is. And I can simply do that by taking the x value of negative 2 and plugging it into my original equation. I'll follow my order of operations. So exponents first. I'll do this multiplication. Whoops. I'll multiply that out. 1/2 times 4 is 2. Minus 4 minus 3. When I simplify all of that math, I get negative 5 as my answer. So my vertex is at the coordinate pair negative 2, negative 5. So I can plot that. Negative 2, 1, 2, 3, 4, 5, negative 5. Okay. The domain, all real numbers for quadratic. We knew that already. The range, I figured that out. This thing opens up. So again, I know that this look a little bit like this. So my range is going to be negative 5 to infinity. Or if I wrote it as an inequality, y is then negative 5 to negative. Okay. The y-intercept, I still find that exactly the way. I plug in 0 for my x value. But that is very easy. 1 times 0 squared is plus 2 times 0, which is 0. Minus 3 gives negative 3. So I can plot that coordinate pair of 0, 0, 3. Because of the axis of symmetry, actually bonus point. That's right over there as well. Very nice. Now, a table of values. Table of values is a little better here. A little bit. I'm going to create a table of values. I'll still put my vert here in the middle. And we still have this idea of symmetry that I can use. I'll build up my table this direction. I'll build down my table in this direction. And I will use a pattern that I know about quadratic equations. And that is that they increase by a pattern of increasing odd numbers. 1, 3, 5. However, I also have to remember to multiply by whatever the a value is as well. So in this particular problem, it's going to be 1 times 1/2. 3 times 1/2. 5 times 1/2. So if I look at this, 1 times 1/2 is 1/2. So my value is going to increase. So negative 5 plus 1/2 will give me negative 4.5. 3 times 1/2 is 3/2. Okay, which is equal to 1.5, right? 1.5. So negative 4 plus 1.5 is negative 3. And then 5/2 is equal to 2.5, which is where I'm going to come up with the next value. Negative 3 plus 2.5 is negative 0.5, or negative 1/2. Because of symmetry, I still have that going on, so I can still match up these values pretty easy by using the idea of symmetry. Now, if I plot these points, I'll be able to come up with a pretty good graph. So, negative 1, negative 4.5, 2, 3, 4, half. Symmetry. I have negative 2, negative 5. Sorry. 0, negative. Check it out. I already had that point. 1, negative 1/2. And again, a point on the other side. So once I made a graph, a quadratic equation fairly accurate. Now finding the x is a little more difficult, and we'll talk about that later on.